Hello, everyone. Everyone can hear me well? Cool. Enjoying the conference so far? I don't see the energy. So today, I'm going to be talking about the new features introduced in React 18. How many of you are working on React? A lot of. And how many of you are already working on React 18? Oh, that's still quite a few people. So I hope you find something interesting, and those who are not may find reasons to upgrade. So we'll go through almost all the, the presentation. Yeah, cool. So today we are going through almost all the new features introduced in React 18, including automatic batching. Then we talk about concurrency, which is the breaking change in this version. We'll go through a couple of the new hooks introduced, including useId, useTransition, and useDeferredValue. Then we talk about Suspense, what is Suspense in general, and what has changed in Suspense in React 18. And finally, we talk in brief about React Server components. But before we start, let me introduce myself. My name is Aashima. I'm working as a front-end engineer in Amsterdam. If you have any questions after the talk, you can, of course, ask here, but feel free to reach out on LinkedIn or Twitter. All the coding demo and the slides will be available on GitHub, so feel free to check it out after the talk. So first, we talk about automatic batching. So we know that whenever there is a state update, React does a re-render. Batching is when React groups multiple state updates in a single render for performance benefits. To understand this better, let's look at an example. Let's say we have two states. One is count, and the another one is active. And we have an event listener increment count, which updates these two states. So now, what do you think? How many renders? So what React does is that it automatically batches these two state updates in a single render, which means that there will only be one render for both these state updates. However, if these state updates are wrapped inside any asynchronous function like setTimeout or inside .then callback of fetch, React does not batch these state updates, which means that there will be two renders in this case for the two state updates. But now in React 18, all the state updates are batched out of the box. But just in case you don't want React to batch your state updates, you can use this function flushSync and call your state update inside the callback of flushSync, which tells React to make an extra render for this particular state update. Next we're going to talk about is this new hook, which is useId. So useId hook allows you to generate unique IDs which are consistent across server and client. Now, why do we need unique IDs? We need unique IDs for accessibility, because in order to support accessibility, we need to use ARIA attributes like ARIA live, ARIA described by, and these attributes heavily rely on unique IDs. So let's say we have a form component which has only one field, which is a password field. Now, one way to provide an ID is using a hard-coded ID, which in this case, I'm using password hint. But using hard-coded IDs is not a good solution, because this component might render multiple times on a page. And in that case, the IDs will no longer be unique. So what we can do is that we can also use math.random and generate unique IDs with math.random. But the problem here is that with the server-side rendering, because math.random will generate random IDs every time. And if you are doing server-side rendering, there will be an ID mismatch during hydration. So we cannot use math.random in this case. And that's why we have useId hook, which solves this problem of generating unique IDs consistent across the server and client. It's very straightforward to use. You just need to import useId from React and call the useId. And then you can use the ID generated inside your ARIA attributes or even the ID attribute in your p tag. Now, let me ask this one question here. What if you have more form fields, like first name and last name? And there can be even more. And we want to provide unique IDs to all of the form fields. So we can definitely call useId for each of them, but that's not very efficient because form can be very large, and it's not good to call useId so many times. So what we can do instead is that we call it once, generate the unique ID once, and then we use it as a prefix for the rest of the form fields. Like here, I'm appending first name after the unique ID which I have generated. And similarly, we can do it for last name, password hint, and if there are any more fields. And this is how the IDs look like, which you generate. So it is like R0, R1, which basically represents the component hierarchy in the DOM tree. And this also changes if you are using strict mode or not. That is some weird thing about React. When you use strict mode, it does extra renders. So next we want to talk about is concurrency. So concurrent React and concurrent rendering was one of the major change in React 18 because it lays foundation for a lot of concurrent APIs which can be used by developers to improve performance of their application. Now, in order to understand the concurrency in React, I'm going to give you an analogy. Think about you have multiple script tags in your HTML. Now, how HTML would execute them? And that will be in the same order in which they are written. So it will be first A tag, A script gets executed, then B, and then C. Now let's imagine that my A script is very heavy, and it's taking a long time. So that means that my B and C scripts are also blocked from executing because the A script is taking a long time. But in HTML, we have this defer. So we can add a defer and tell HTML to defer the script tag. So now the new order of execution becomes B, C, and then A. And this is what concurrency in React also is. Just that instead of script tags, there are state updates. So before React 18, React would process the state updates in the order in which they are written. So like in this case, first Twitter will do the layoffs. After that, it's Meta, and then Google. But now in React 18, you can tell React that which state updates are the urgent ones and which have the lower priority. So now React can pause, interrupt, and abandon a render. Now let's look into how we can use this concurrency to improve performance of our applications. So I'm going to use this demo. So we are going to filter 5,000 list of items on the client. No offenses, please. This is only for the sake of this demo. So we are going to filter everything on the client by typing in that input box. So the code for it is pretty straightforward. We have two states. One is for storing the query, search query, and the another one is for storing the filtered items. Then on the input change, we add an event listener, filtered items, and we loop over those filtered items to display the filtered items. In the filtered items, it's straightforward, like it will filter it on the basis of user input and set these two states, which is set query and set filtered items. Now, let's see what is happening here when I try to search. So when I'm typing, I don't know if you can notice, but it's like a bit laggy. You can notice it. So I have pressed back already, and this took a while to update. The input box is a bit laggy, and it is taking some time to update. I'll do it again. So I have typed, and now I have pressed back. My hands are up. I've pressed, and it takes time to execute, right? So my input box, as well as the list of items, both are getting updated at the same time. But this is not a very good user experience, because what I want is that my input box to show instant feedback as the user is typing. However, the list of items, it can have a lower priority, so it can lag behind. That is fine for me, but the input box should be instantly updated. So just like the HTML, we want to defer this heavy list of filtered items. My input box right now is lagging because it's filtering 5,000 list of items, and both the state updates are happening at the same time. So here, what I'm going to do is that I'm going to defer the set filtered items. And in React, we can use useTransition and useDeferredValue for that. So we can use useTransition, which returns us isPending and startTransition. And then we wrap the set filtered items inside startTransition, which basically tells React to, OK, this is my non-priority update, so React can do it at end of the render. And now let's see how this works. So if you notice, now the input box is very responsive. It's instantly clearing the input box, but my item list has not been updated yet. It's still showing the stale results. But my input box is very responsive. What useTransition also provides us is with the isPending flag, so which we can use to show the loading state till the transition is still happening. So we can say that, OK, if it is loading, then show the loader, otherwise display the items. And this will look something like this. So when I'm clearing it up, now this time it shows the loading till the list has refreshed. But sometimes it's good to show stale results than not showing anything, like showing a loader. So what we can also do is that we can use opacity. So we can show the stale results and show it grayed out, just to give the feeling to the user that, OK, the list is still getting updated. Now let's consider one more thing. Let's say you don't have control over setting the states of filtered items. So you're not allowed to change that code. So we can also do the same thing using useDeferredValue. So here I have taken out the list inside another component, which is outside, which is item list, and which is getting the list of items. And here I'm going to use useDeferredValue, which will defer this list of items. So this is not an updated list. This is a lagging behind value. And we can loop over the deferred items, and this will give us the same results. I know this gets a bit confusing, so we'll get to another demo for the useDeferredValue so that I can explain it more better. So let's say that there is a button. It's a counter. So as I press, so this should update this list. So as I'm clicking on it, it should update or increment all the list items by 1. And these are 90,000 items. So it's, again, a heavy update. The list is, again, very heavy, and it's going to take a while. So what's happening here is that when I'm clicking, I have pressed 10 times. So now it's still happening, or my button gets stuck. Yeah, so now it's updated. And this is, again, not a very good user experience. The user is clicking on the button, and it's not getting updated. So we are going to improve its experience by using useDeferredValue. So again, we have a button which has on the click, which is incrementing the button value. And then we have an item list, which loops over the 90,000 elements and increments each of the item in the item list. So here, we are going to do is use deferred value. We are going to defer this value. So this works like debounce. So when I'm clicking, my value is getting updated, but my deferred value is lagging behind. It's not getting updated till my renderer is free to update that value. So this is very, think about it like debounce, how it happens. The last call goes when the user has stopped doing something. So this is the same way. When React is free to do the update, then this value will get updated. And here, we will pass this deferred value to this item list component. But still, what will happen here is that my item list component will execute will loop over 90,000 items, but with the old value. So we also need to memoize this, because my value is not getting changed, but my component is executing the list every time. So we used memo so that whenever the value is not changed, we are not computing the array again. And here, we can in order to show is pending, we can say that till the deferred value is not equal to actual value, so we can show the is pending. Otherwise, we show the updated list. And this will look something like this. So now when we are clicking, the button is very responsive. It's instantly clearing, but the list is lagging behind. We show the opacity, like the blurred thing, and then it gets updated, which is OK, but the button is not stuck. So both useTransition and useDeferredValue gives you the same results. But useDeferredValue is used when you don't have control over the state updates, when you cannot use transition there. So this is generally how we use what's recommended by the React team to use deferred value. Are you guys familiar with the React beta docs? Like, has anybody tried the new beta docs? Yeah, that's pretty good. And you can go through the use deferred value. I think use deferred value got updated recently, so feel free to go through it. And it has a very nice explanation and everything to explain what all cases we can use deferred value. I know it's like, so also remember that use deferred value and use transition, they are doing an extra render. So if you are using it too much, they are going to make your application slower. So so when you're using it, just make sure you use it wisely and not overuse it. I know it's a lot, so I'm going to pause for like 2 seconds and let it sink in before we move to our next topic. So next we have is Suspense. So I think everyone here must be familiar with Suspense. Is it like anybody is using Suspense? You're using, OK. So Suspense has been there for a long time. It was there in React in 2018. What Suspense does is that it simplifies to add loading state when the part of component tree is not ready to be displayed yet. So let's say the first use case for the Suspense is to display fallback for the lazy loaded components. Like here, if I import a profile, I'm lazy loading this profile component. And if I wrap it inside Suspense, now till the time my profile is not ready to be displayed, Suspense will display the loading component. Another big use case for Suspense is in data fetching. But this is like a misconception, because many of the people think that Suspense can only be used for data fetching, but it can be used for any asynchronous code. Just that whatever you are wrapping inside Suspense has to work with the Suspense API. So let's see how we can use it for the data fetching. So with the data fetching, let's see we have a post component which fetches a couple of posts, and it goes through the post and displays the list of posts. So now we import this inside our Suspense. So now what it does is that till the posts are ready to be displayed, my Suspense will show the loading component. Now here, because both the profile and posts are inside this parent Suspense component, so till both of them are ready, Suspense will show a fallback. But sometimes you want to show the profile because it's ready, even though the posts are not ready to be displayed yet. So what we can do here is then we can use additional Suspense to wrap the posts inside another Suspense fallback. So Suspense makes it very easy to use multiple loaders. When you have 3, 4 loaders, it lets you control those loading states very easily. And yeah, so one thing which I already mentioned is that in order for Suspense to work, so you need to make sure that how you are fetching that data. So that has to be compatible with the Suspense API. So if you're using Relay or Next.js, you are good. Otherwise, you might have to write additional code to make it work with the Suspense API. Now let's say there are some errors in this component. So to handle that, We can wrap it inside the error boundary, which will take care of if any of those components fails, then it provides a fallback for the error component. So this is what Suspense in general is. It existed before even React 18. But before React 18, the Suspense was only supported on the client, and the major use case it was solving was code splitting. But now it's also supported on the server. So let's say we have this page which we want to render from the server. So we have this navbar, profile, and the post. And the post is an asynchronous component. It's calling a heavy API and executing the post. So even if we want to do it, send it from the server, we need to load everything on the server. So it's going to take a while for posts to load, and then before we can send everything to the client. But now with Suspense, what we can do is that we can, till the posts are loading, so we can provide a loader, and we don't have to wait for the post to completely load before sending data to the client. So this is called like streaming HTML. We are able to stream the HTML even before my posts were not ready. But the server-side rendering does not end at just sending HTML to the client, because after the HTML has been sent to the client also needs to download the code. The hydration will happen, because this is only the static content. But what Suspense allows is also selective hydration. So once my nav component and profile is ready, so Suspense can make sure that these two components can be hydrated separately. And after this posts are ready, the post component will get hydrated separately. And this solves like a major problems on the server-side rendering. So next thing we are going to talk about is server components. Are you guys familiar with server components? Anybody used it or? Yeah, so this was introduced in React 18, but was launched with Next.js. It was in alpha, but until I think last 2 months back, with Next 13 has launched it in beta. So in order to understand React server components, first talk about the rendering strategies that we have. So we have client-side rendering, and we have server-side rendering. In client-side rendering, when user requests a website, server sends like a blank HTML with a script tag, bundle.js. Browser then downloads the JS file, React gets loaded, and then additional request is sent to fetch the data from server. Once the data is returned from the server, the content becomes visible and interactive. Now, this works great for building high-user interactive websites, because you can choose to reload the components which have been changed instead of reloading the entire page. But the problem with client-side rendering comes as you ship more and more code to your client bundle. So as you ship more code, the bundle gets heavy, and browser takes time to download the JS. And as a result, we get delayed FCP. Also, with client-side rendering, we have SEO problems, and you're not able to run them on non-JavaScript devices. So we also have server-side rendering. And in server-side rendering, when user requests a website, this time server sends a fully rendered HTML. But this is just a static data, and it's not interactive. So what browser does is that it also parallelly downloads the JS file, and then comparison is done between the version which is generated by the client and the HTML that was sent from the server, which is called hydration. After hydration, React takes control, the content becomes interactive, and everything works like a normal client-side rendered application. And the huge benefit we get from SSR is improved FCP, because browser does not have to wait to download the bundle in order to show content to the user. And also, the SEO problem is solved. But server-side rendering can only be used during the app load. After hydration, the entire application behaves like a normal client-side rendered application. Now, some of you might say that with Next.js, you can create multiple routes, and on each route, you can do server-side rendering. But the problem is that the state of client components is not maintained as you switch between those routes. And that's why we got this another concept, which is React server components. Now, in client-side rendering, all the components in the DOM tree are generated on the client. In the server-side rendering, all the components are rendered on the server. But in React server components, some of the components can be rendered on the server, and some of the components can be rendered on the client. And when I say that components are rendered on the server, it does not mean that it's server-side rendering. In fact, React server components can be used on top of React server-side rendering. Because in server-side rendering, what's happening is that it converts everything into a raw HTML before sending it to the client. So what we can do here is that during the first page load, we can use server-side rendering. And server this time will send the HTML. And when you switch between the route, this time you can ask the server to send, you can use RSE, and the server this time will send you a JSX-like object, which will look something like this. So this is like not like exactly like a JSON. So this has the client files. And in the client files, you can see the chunks are empty because this is not rendered. And on the fourth, if you see this, there is a server component which is fully rendered, and that is sent to the server. So all the code which is done on the client, on the server, it's not sent to the client. So all the server components code stays on the server and is only sent as a string to the client over the network. So which means that nothing gets added to the client bundle. And the benefit of using rendering components on the server is that because components are rendered on the server, they can directly access DB and file system. And server is good at making faster computations, and it's more secure. So all in all, the main idea for React server components was to let server do what it is good at, and let client do what it is good at. Server is good at making computations. So do the computations on the server, and do the interactivity part on the client. So as I mentioned, the huge benefit we get from the server components is none of the server code is added to the client bundle. And we get access to the DB and file system, which makes data fetching really fast. I think that was it which I want to talk about React server components. If you feel free to check out the slides on this app. And if you have any more questions, feel free to reach out. And there are code examples also on the GitHub.